Okay, so we start. I think we can start. So the main purpose of this QGIS tutorial is to show how you can know the storage in in Rwandan catchments. So first of all, we will start by opening QGIS. So I think we should load a new project because these are the other ones I've been working on. So everyone, I think, has this blank page. So can we proceed? The other step is to load the base map. Like the base map, the easy way to get the base map is to install a plugin called CMGIS. For me, I've already installed it, but anyone who wants it can insert it here. HCMGIS, then you click on it, then you click on install. So everyone with this plugin then can load a base map. The only thing you do is to come here in the tab section, then you click on HSMGIS, then you load a base map. The base map we'll be using will be the Google Satellite base map. So I hope everyone is here.
Yes.
This is the base map. Yeah, it shows you where you are currently doing your things, like in which region are you. So the other thing we are going to do is to upload the precipitation dataset. As I said, the main objective of this tutorial is to calculate the storage in every catchment of Rwandan region. So we have to upload the precipitation dataset. Here is how you do it. You come here, you specify that the dataset that you are going to upload is a raster dataset. Of course, the precipitation dataset has to be a raster format. Then you search, you navigate where you have those data. Okay, mine are here in extracted files. Then Rwandan precipitation dataset, we'll be using 2020 precipitation dataset. Then I hope everyone will have already reached here and you have opened. I hope everyone have opened this dataset. And if you could zoom, you could see that this dataset goes beyond Rwanda. It is an African dataset. So the next step is to clip so that we can remain with Rwandan dataset. So how will we do that? The first thing, we need a shapefile of Rwanda so that we can clip this dataset. So everyone will go to this website. There is a website here which has all shapefiles of all countries here. You can write Rwanda shapefile. Rwanda shapefile, then add this word diva because it is the name of the website. So come here on diva. Is everyone here? On Diva website, we are going to download the shapefile of Rwanda. You specify the country. Our country is Rwanda. So Rwanda, then the subject will be administrative areas. Then the format, you choose a zip format. Then you download it. I've already downloaded it, but everyone can download it. And let me know when you are done so that we can proceed with QGIS. So, those who already downloaded the zip format, we should go in our laptop directories. Then you find the shapefile you downloaded. It will be having this name. Then you extract. You will have to extract it. After extracting it, you will find a folder which is extracted. Then you will come here in QGIS again. Then you do what? You upload the shapefile you have downloaded. For your information, a shapefile has to be a vector format. It is more likely that you will not find a raster, which is a shapefile. So what we are going to upload is a vector file. We come in our downloads, then we go in Rwandan folder, then we search a shapefile. I hope this one is a shapefile. So we have to open it, then we click on add. Then our shapefile is already uploaded. We can cross the tab. We can cross the tab. I think everyone can see that here is our shapefile. If you could untick other data, I hope you can see that we have a Rwanda here. This is our shapefile. Everyone can see it. So the next step is to clip the precipitation data we had with this shapefile. So how do we do that? We come here on database, raster. Then we click on extraction, clip raster by mask layer. Our mask layer will be the shapefile we have downloaded. Then the data we want to clip is the precipitation dataset. It was African dataset, then we want to turn it into Rwandan dataset. We want to remain with Rwandan dataset only. So our input layer will be the African dataset, then we clip it. We are going to clip it. Everyone can click on run. And then you close. So let's continue. Let's continue with our model. As we said, the model is all about to find storage in Rwandan catchments. So right now we have the precipitation dataset. So we need what? We need evapotranspiration so that we can get the storage, assuming that the discharge equals 0. So everyone has to navigate to where he saved his evapotranspiration dataset. Of course, it has to be a raster format dataset. So I think everyone has this folder. It contains evapotranspiration dataset for Rwanda. Then we do what? We upload it in QGIS. Right now we have evapotranspiration dataset. Then we can do a storage map. To do a storage map, we will come here on raster, then raster calculator. Then we do what? We take the precipitation dataset. We subtract the evapotranspiration dataset. Then we create another layer which will be temporary. We can name it P minus ET. so that everyone who is new to this file can even detect that this layer represents storage. So when you click OK, you will see that we will be having another layer which represents the storage of water in Rwanda. But our aim is to have every statistics in every catchment. So we don't need the whole storage in Rwanda. We need in every catchment. So the next thing we have to do is to find the shapefile of the catchments in Rwanda. So let's go on the internet. Everyone open your browsers. Then the best way to get it is to write what you need. We want Rwanda catchment shapefiles. And what you should know is that these shapefiles have to be level 2. What it means by level 2 is that it is on a country level. When it is level 1, it is on continental level, then level 2 is country level. The first site that comes is Rwanda Water Board. Navigate to their website. They have catchment level 2 dataset. In Rwanda, then you can download these layers. Make sure you download a zip format. Everyone download a zip format of this dataset. So it's here, the same process. You have to go in your folder where I downloaded the zip format, then you extract it. This time it is called catchment level 2. So everyone, I hope you have extracted these shape files of catchment here in Rwanda. Then we will come here in QGIS. We are going to upload what? We are going to upload the shape files of catchment here in Rwanda. We will click on add. Then of course it is a shape file, so it has to be a vector format dataset. Okay, this is it. No, it is not this one. I think we have to navigate to the folder. This is the catchment folder. Then you see a shape file. You open it. Let's add it in QGIS. So this is the catchment. These are the catchments here in Rwanda, and this is the shape file. So the next thing you have to do is to learn a zonal statistics. Zonal statistics means like getting storage in every catchment of Rwanda. At this time, we are not working on the country level. We are working on the catchment level. So everyone has to come here on this search box, then write zonal statistics. Zonal statistics, we want to do zonal statistics on which level? On the catchment level. Then the data set we want to analyze is which one? We want to analyze the storage data set, our area P minus ETs. So let's learn it. Okay, you see we received an error which says our catchment level data set has invalid geometries, so we have to fix them. The way we can fix them, first we check which errors are in the data set that we downloaded. Check validity. Then we specify what we want to check. We want to check this data set. What are the errors in it? Then we click Learn. So I hope everyone can see that we got extra layers. Like we got an error layer, an invalid output layer. Then we got an invalid output layer. basically what this means is that in the catchment data set, there is a certain part where data is not specified. There are areas where data is specified, so we have to fix everything. So let me try to be clear and remove other layers so that maybe you can see what an error so you see in this part of catchment dataset we have, there is no varied dataset, so we have to provide them. And you can see that in this part is specified, but the other part, this one is not specified. This invariant part is not specified, so we have to fix it. So how do we fix it? You come here in the search box, then you write fix geometries. So what do we want to fix? We want to fix the invariant output dataset. That's what we want to fix. Then we do what? We learn. Now I hope you can see we got another area which says fixed geometries. So now we have a fixed geometry. Then we can combine it with our varied dataset so that we can get a new catchment file which we can work with. Because the other one contains errors, these steps are correcting errors in the dataset. So how will we combine the fixed dataset we have right now with the other varied output we had earlier? We will use a tool which is called merge. We will use merge vector layers. So which layers do we want to merge? We want to merge the layer we have corrected, which is a fixed geometry layer. Then we want to merge it with the other varied layer we had earlier. Then we click on Learn. So I hope you can see right now we have a catchment dataset which is full, that we can work with our zonal statistics to get storage in every catchment in Rwanda, so that we can know, like, in this catchment we have this amount of storage, in this catchment we have this and this. So now we can continue with our zonal statistics. I hope this time it will work. Zonal statistics. Yeah, zonal statistics. Zonal statistics. Which layer that represents where we want to perform our statistics? Of course, it is the catchment dataset, because we want to perform statistics in every catchment. So the catchment dataset that we corrected is this merge. Then we specify the dataset that contains the storage. It is this P minus ET. Then we specify the name of the output dataset that we will be having. It will be a what? Maybe it will be a zonal statistic. A zonal statistic layer. Then we can click on Learn. I hope you see right now we didn't get errors, because the catchment dataset we are using, it is now corrected. Then we click on Cross, and right now we have a new dataset in which we can get the statistics of storage in every layer. Let me carry it so that you can view it in a better way. I will make it graduated. Then I want it to show the mean. Okay, the color has to be, let me choose this color. I like this one. So I'll choose this color. We will go with a spectral color lamp. Then when you reach here, what you do classify. So basically what this means, we have a new map, but we want to know information from the map we have. Like the map will be showing us colors, and those colors will be representing storage in different catchments of the dataset that we'll be having. So you see, the red color will be representing storage from this range. Then this brown color will be representing this range. Yeah, till you reach here on blue. So that's it. Then you can click on apply. Then okay. Then right now you see we have a new map which shows the storage in every catchment. In this catchment, we have this color. In this catchment, we have this color. And every color has a meaning. Like this red color means low storage, large storage, I mean. Then this color means maybe medium storage, less storage. Yeah. This is it. This is what you can do with zonal statistics. And the other thing which is better is that you can know the amount of storage there by looking into the attribute tables. You come here on attribute tables, you open attribute tables, then you can see in this region, we have this area, we have whatever, like it shows you everything, all the information you have. Yeah, thank you for your attention.